Hello viewers, welcome back to my channel. In the previous few videos, you have already seen what exactly is data encryption standards. It actually used to be one of the most popular algorithms around the 1980s. But later on, due to its weaknesses and vulnerabilities, it was slowly being replaced by Advanced Encryption Standards. In this video, I'm going to introduce you all to what exactly Advanced Encryption Standard is all about. And in the next few videos, we are going to see in detail the internal rounds of AES. So without wasting much time, let's get started with this video. So viewers, as promised, let me introduce you all to what exactly Advanced Encryption Standards is all about. So first of all, if you talk about Advanced Encryption Standards, it comes in three different varieties or three different types. First one is AES 128, then AES 192, and third or finally AES 256. So we are going to focus on these three variants of AES, specifically AES 128, right? So what exactly happens in AES 128 is, as the name suggests, AES 128 works on 128-bit blocks. As you saw in the case of data encryption standards was having a block size of 64 bits. But if you compare it with AES, already we can see a difference, that is, it is of three types: 128, 192 and 256. So this is the very first difference between AES and DES. Secondly, what exactly happens in the case of AES is, depending upon the block size, there would be different sized keys. As we already know, in the case of a block cipher, the key size and the plain text size should be equal. So depending upon which AES version you are using, there will be keys of size 128, 192 and 256 respectively. Clear? So this was all about the basic introduction of what AES block structure or block cipher looks like. Now let's go back and let me show you a diagram. This should make things easier for you to understand. As you can see on your screens, this is how the AES cipher looks like. So over here, I am going to focus on the AES 128-bit version for you to understand what exactly AES is. Fine. So what exactly happens over here is, the block cipher works on a 128-bit block. It is basically nothing but 16 bytes in length. If we say 1 byte is 8 bits, it comes out to be 16 bytes. So I can say that the 128-bit ka block is also equal to 16 bytes ka block, right? So what exactly AES does is, it now converts this 16 byte ka block into a 4 by 4 matrix, which is nothing but 4 byte by 4 byte, in short 16 bytes. So this particular matrix is what we call as a state array or state matrix. AES works on this particular state matrix. Now as you can see, the initial value or the initial state matrix is of 16 bytes. It goes into a transformation function, as you can see over here. This transformation is quite similar, or we can say it sounds similar to what we had in DES, that is initial permutation. But internally it is totally different. Just assume that some sort of internal wrangling of the bits, internal interchanging of the bits happens in this step, and we get the plain text which actually undergoes AES. So in short, there was an initial plain text. It was converted into a 4 by 4 matrix, which is what we call a state array, that undergoes some sort of initial transformation, and we get the actual plain text which undergoes AES, right? So what now happens is, depending upon the block size, depending upon the plain text size, AES can have multiple number of rounds. So for example, AES 128 will have 10 rounds. If you can see over here, AES 128 will have 10 rounds, AES 192 will have 12 rounds, and AES 256 will have 14 rounds. So again, I'm repeating, depending upon the block size, the number of rounds will vary. For 128-bit AES, there will be 10 rounds. For 192-bit AES, there will be 12 rounds. And similarly, for 256-bit AES, there will be 14 rounds. So after the initial transformation step that we saw just now, the state matrix is in front of us, which is again of size 16, that is 4 by 4. Now what happens is, if you see over there at the top, the initial transformation has two inputs. The first input is nothing but the state matrix or the state array, and the second input has to be a key. The key is generated from this function called as key expansion, which we will learn in detail in the next videos. But for the time being, just understand this. If we have a 16 byte ka input, then we should expect again a 16 byte ka key. Clear? So with this, we can conclude that for this initial transformation, we will require a 16 byte ka key. So that 16 byte key is supplied using some key transformation function that we will study later. So the first step is done, that is we have obtained the initial matrix which will undergo transformation. So with that, the round number 1 begins. Now what exactly happens in round number 1 is, as you can see over here, the output of the initial transformation goes inside as one of the inputs to the round number 1, which has 4 transformations happening inside it, or we can say that 4 operations are happening inside each round until we reach n-1 round. So in our case, we are using the 128-bit version of AES, so we will be having 10 rounds, right? So in my case, my n value is nothing but 10. For the first 9 rounds, that is n-1, that is 9 rounds, we will be having 4 transformations in each round. But for the 10th round, that is the final round, we will be having only 3 operations. So if I scroll over here, you will be able to see that for the first n-1 rounds, there will be 4 transformations in each round. But for the last round, that is the 10th round, we will be having only 3 transformations. So that sums up how AES works. So if you see this diagram, for each round there is one key that is being used or that is being supplied by this key transformation function. So in total, how many rounds are there? There are 10 rounds, right? Similarly, there is one round which actually creates your initial matrix. So in total, there are 10 plus 1 rounds, that is 11 number of rounds, starting from round 0 to round 10. Clear? So what exactly do we need right now? What exactly happens is, there is a key expansion function which operates on each round block, and it provides some sort of key for each round. As you can see, round 1 key, round 2 key, till round n-1 key, and finally for the next round as well, which is the round number 10. So in each round, we are going to get some sort of key which is being supplied by this key expansion function. So can you now tell me how many keys are being provided by that key expansion? In total, 11 keys. And what is the size of each key? It is basically 16 bytes. Now, can I say that one word is equal to 4 bytes? Or it's just basic computer science. We know that one word is nothing but equal to 4 bytes. So, can I not say that 4 words is equal to 16 bytes? Yes or no? We know that 4 words is equal to 16 bytes. So I can easily say that the 16 byte ka input, that is nothing but 16 byte ka input matrix, is nothing but equal to 4 words. Similarly, that many number of keys will be provided in each round as well. So I can say that in total there will be 11 rounds into 4 words, that is 44 words ka key will be used in total for those 10 plus 1 rounds, that is round 0 plus 10 rounds of AES. Actually speaking, there are only 10 rounds, but there is one initial round also, so that makes it 10 plus 1, that is 11 rounds. So at the end of those 11 rounds, we will be obtaining a cipher text which is of size 128 bits as well. So at the end, the final state matrix will be of 16 bytes, and that is how AES works. So this was all about the introduction of AES. I hope you liked it. Stay tuned for the upcoming explanation of how the internal rounds work on AES. This was just an introduction. We are still left with what exactly are those transformations that happen inside AES and how the keys are being generated. So stay tuned for the further videos. Till then, take care. God bless you.